Today we're going to be talking about the properties of logarithms and how we can use them to simplify some expressions and also to expand and condense logarithms. So first I wanted to just go over what a logarithm is. So remember that a logarithm is another way to write an exponential equation. So if you have y equals log base a of x, that's the same as a to the y power is equal to x. Also a reminder that we have two special types of logarithms. This first one is called the common log. Oops, let me make sure my pen is turned on. So remember that the common log has a base of 10, and it's so common that we just don't even write the 10. Okay? So whenever you see just a log of x, that means the base is 10. And then the other special log base that we have is called the natural log, and it has the base of e. It's called the natural log because it comes up really frequently in nature, okay, and just naturally in the world. And whenever we have log base e, we rewrite it as the ln of x. So all of the properties that we are going to go over work for any logarithm with any base, okay? Now remember with logarithms, our bases are always going to be positive whole numbers, okay? And so yeah, you can generalize any of these properties to any base. So as we go through this table, a couple of things to know is that we're letting M, capital N, and A just be any positive numbers. We are going to say that A can't be 1. And we're letting R be any real number. So that means that R could be negative if we wanted it to. Okay. There's 4 different types of properties we're going to review, or we're going to learn. The first are properties that are based on the definition of logarithms. And some of these we've already talked about. So the first one is that log base A of A is equal to 1. So remember that when we're trying to evaluate logs, we say the base to what power gives you the argument. So A to the first power gives you A. So whenever the base and the argument are the same, it's always going to be 1. Just like over here in this example, we have log base 2 of 2 equals 1. The next one is nice. Whenever you have log base A, so log with any base, and you have a 1 as your argument, it's always going to be 0. And the reason why is because A to the 0 power is equal to 1. You see that over here, we have log base 11 of 1 is just equal to 0. Okay, the next two properties are really closely related. So if we have an exponent like A and the exponent is log base A of M, since this exponent base and the base of the logarithm are the same, we can cancel them out and we're just left with M. So in this example over here, you'll see 4 to the log base 4 of 5 equals 5, because you can just cancel out the 4 and the log base 4. And the next property is kind of the opposite version of it. If you have log base A of A to the R power, you can also cancel out those, the log base A and the A, and you're just left with R. So in the example, we have log base 4 of 4 to the 5th is just equal to that 5, that exponent. So we are going to go ahead and use these properties really fast to do some simplifying, okay? And then we're going to come back and talk about the power product and quotient rule. So I'm going to go ahead and zoom out so that we can see the properties and the examples that we want to do. So with these properties, the ones we just talked about, they're going to allow us to evaluate logarithms. When we say evaluate, it means that we're going to be able to rewrite this logarithm as just a number. It's probably going to be a whole number, and it's probably going to be positive, or it could be negative as well. But we're going to evaluate them. So log base 4 of 1, that's our property that says whenever the argument is 1, that is equal to 0. 5 to the log base 5 of 3, we can cancel out the 5 and the log base 5, and we're just left with 3. Same with the next one, log base 7 of 7 to the negative 1. We can cancel out the log base 7 of 7, and we're just left with that exponent of negative 1. All right, the next one says the ln of e. So before we start thinking about this one, let's remember what the ln is. Remember that the ln is the same thing as saying log base e of e. And that looks a lot like our very first property up here in the table. Log base a of a is always equal to 1. So this whole logarithm just evaluates to 1. Now the next one, log base 2 of 64. This one does not look like really anything up there in our property boxes. So what I'm going to do is I'm actually just going to rewrite this. Log base 2 of, and I'm going to rewrite 64 as 2 to some power. So I'm thinking, okay, 2 to what power gives me 64? And in this case, it's 2 to the 6th power. So I can rewrite this as log base 2 of 2 to the 6th power, which then allows me to cancel out the log base 2 and the 2, and I'm just left with that exponent, which is 6. Okay. The next one has another natural log in it, another ln. I'm going to zoom in on this one so we can actually see it. So I'm going to start by rewriting that ln as log base e. Now you don't have to do this. I'm rewriting it as log base e so that we can really see why this property works. But hopefully you get to the point where you do not need to change the ln or the natural log to log base e. So the reason I rewrote it is because now we see that we have e raised to the power of log base e of x minus 3. So I can cancel out both the e and the log base e, and I'm just left with x minus 3 as my answer. Okay. So hopefully that was helpful practicing using those definition of logarithm properties. What we're going to do now is we're going to jump into 3 other kinds of properties called the power, product, and quotient rules. So the power rule, powers, remember, are exponents. So this rule helps us when we have exponents that are embedded within a logarithm. So let's say we have log base a of m can be any number, raised to the r power. Okay. What I can do is I can take this exponent and I can put it in front of my logarithm and make it r times log base a of m. So for example, if we had log base 5 of x squared, I could bring this squared in front of my log and make it 2 log base 5 of x. The product rule has to do with when you're multiplying. So remember, product is multiplying. So if we have log base a of m times n, so here we're multiplying 2 numbers or variables together inside of a log. What I can do is I can actually separate this log into 2 different logs. I can make it log base a of m plus log base a of n. So you just take the 2 things that you're multiplying together and you separate those, and they each get their own logarithm that you then add together. So over here in the example, you'll see log base 2 of 3x. Now most of the time when we see 3x, we just think of it as the same thing, like as 3 and x as being one unit together. But this is really 3 times x, which means I can chunk this up and separate it into log base 2 of 3 plus log base 2 of x. Now you might be wondering why I would ever want to break up a log from one log into 2 different logs. Okay, it's a really good question. Probably more useful in many ways is going the other direction. So if you start with 2 logs, wouldn't it be nice if we could just go backwards and write it as 1 log? And that's what we'll be doing a lot of. We'll be working on changing multiple logs into just 1 log. But we will practice expanding the logs as well and making it and turning them into like several logs added together. Okay, and our last rule is the quotient rule. And we do the quotient rule when we are dividing 2 things inside of a logarithm. So I have log base a of m divided by n. I can separate this into 2 different logs, log base a of m minus log base a of n. So in my example over here, I have log base 5 of 10 over x, which I can change into log base 5 of 10 minus log base 5 of x. Okay. So these 3 rules that we did at the very end here, we are going to use these a lot to expand and condense logarithms. So expand just means separating them out into multiple logs, and condense means kind of pushing them all together into 1 log. It's also important to know that these 3 rules, the power rule, the product rule, and the quotient rule, really depend on and work because of rules of exponents. So remember that your logarithms and your exponents are really, really closely tied together. So these rules can be proven using your exponent rules. Okay. So let's go ahead and jump down, and we are going to practice using these three rules, the power, product, and quotient rule, to expand and to condense. So first thing we're going to do is we're going to work on expanding. So what we're trying to do is, instead of having one logarithm, we're trying to break this down into as many different pieces as we can. So in A, I have the log of 5x. And again, this is like a 5 times x, which means that I can use my product rule and make it log of 5 plus the log of x. Okay. One thing to note here is that there's not a base on this log, so it's a common log, which means the base is 10, and I don't have to write it. Okay, in B, I have the natural log, or the ln, of 3 over x, so I can separate this into the natural log of 3 minus the natural log of x. So remember, the division inside the logarithm results in two different logarithms that are being subtracted. Next one is log base 7 of x to the 5th power. So this is going to be the power rule. So I can bring that 5, instead of being an exponent, I can bring it in front of the log and make it 5 log base 7 of x. Okay. All right, let's go ahead and take a look at some. So these first two examples are very basic. We just used a power rule, a product rule, or a quotient rule. Now we're going to look at using multiple rules in the same problem. So in D, I have the natural log, I have the natural log of x squared e to the x. Let's remember that the x squared and the e to the x are being multiplied together, which means that I can separate this into the ln of x squared plus the ln of e to the x. Then I'm going to go ahead and do some other, apply some other properties. So one thing I can do is I can take this 2, that's an exponent on the x, and bring it in front of my logarithm. So it's going to be 2 natural log of x. Okay. Now this next one, I'm going to do something a little bit different. I know that the natural log is the same thing as log base e of x. So I have log base e of e to the x. And I can use one of the first properties that I talked about to cancel out log base e and e. And I'm just left with an x. So what I have here is 2 ln of x plus x. And that would be my final expanded version. So your goal here, like the way you know you're done, first of all, you want to make sure you don't have any exponents. Okay, so because if you have an exponent, you can probably do the power rule. So you want to make sure you have no exponents, and you want to make sure that in every log or in every natural log, there's just one type of thing, right? There's one x, there's one y, or there's just a number, but you're not going to have like a mixture of variables and numbers inside of the same log. Okay, let's look at the next one. The natural log of y to the 4th over x to the 5th. So I'm going to start by using the quotient rule to separate this into the ln of y to the 4th minus the ln of x to the 5th. So now I've satisfied the idea that every variable has its own logarithm. Now I need to get rid of all my exponents. So I'm going to take this 4 and put it in front of its logarithm, and this 5 and put it in front of its logarithm. So you have 4 natural log of y minus 5 natural log of x. Now one thing you want to be careful of is you want to make sure that you keep whatever exponent you pulled off of one logarithm, it only goes in front of the logarithm it was pulled out of. Okay, let's go ahead and do our last one. So this is the natural log of e times x cubed. So it's going to be the natural log of e plus the natural log of x cubed. The natural log of e, remember that's log base e of e, which is just going to turn into 1. And then I'm going to do the power rule here to make this 3 natural log of x. And that would be my final simplified version of that one, or final expanded version. It's really not as simple, right? We've expanded it into several logs. Okay. In this next set of examples, we are going to go the opposite direction. So we're going to take the power, product, and quotient rules to condense these logarithms. So we're going to try to take maybe 2 or 3 logs that are being added together or multiplied or subtracted, and smash them all together into just one log. So I'm going to do here, in A, I have the ln of 8 plus the ln of x. So I notice that since I'm adding 2 logs, and they have the same base, they're both a natural log, I can use the product rule. So I can make this the ln of 8 times x. Similar with the next one, I have log of u minus the log of v. So I'm subtracting 2 logs that have the same base, so I can make this the log of u over v. Okay. And then in this last one, in C, not the last one, but in C, I have a constant that's being multiplied in front of the log. So what I'm going to do is whenever I have a constant in front, I can just bring it up and turn it into an exponent. So it's going to be log of x to the 1/4 power. Okay, let's go ahead and do some other examples. And in these ones, they're going to get a little more complicated, and we're going to be combining several different log rules. So first, what we're going to do with this one is I'm always going to start by taking care of any constants that are in front of my logarithms. So in this case, I have a 3 in front of a log, so I'm going to take that 3 and make it an exponent. So I have log base 7 of u plus log base 7 of v to the 3rd power. Okay, now that I have all of my constants taken care of, I'm going to look and see if I can do either the product rule or the quotient rule. Since I'm adding, it means that I can do the product rule, and I can multiply those two things that are inside of the log together. So log base 7 of u v to the 3rd power. Okay. If you're starting to feel like you're getting this, why don't you hit pause, try a couple on your own, and then come back and check your work. So I'm going to start in this next one by getting rid of all of the constants in front. And I'm going to do that by changing them all into exponents. Okay. And it's important to note that you have to have those constants gone before you start doing the product and quotient rules. So always start with the power rule. Then we have a bunch of things that are being subtracted, so I can do the quotient rule. So I have the ln, and I have u to the 4th, that's what goes on top of my fraction. Then I'm subtracting a v to the 3rd power, and I'm also subtracting a w to the 2/3 power. Okay, so since I'm subtracting both of these, they're both going to go on the bottom of my fraction. Okay. All right, let's look at the next one. Now I'm going to show you a common mistake that people make with this one. So here's the right way to do it, and then I'll talk about the common mistake. So the correct way is first look for any constants that I could turn into exponents, which I don't have here. So I can skip the power rule. Then I have 2 logs that are being subtracted, which means I can do the quotient rule. So I have the log of x minus 4 divided by 6x plus 5. Okay. So here's the common mistake that people make. People often want to take, let me just do this example. I'm going to do it down here in red so you know this is wrong, okay? Let's say I have the log of x minus 4. Okay. What people often want to do is take that one log and separate it into the log of x minus the log of 4. Okay. We can't do that because this is kind of like, looks like I'm trying to use the quotient rule, but to use the quotient rule, you have to be dividing inside of your logarithm. The other thing that people will try to do is they will say, okay, I have this log of x minus 4, and they know, well, I know that the subtraction goes with division, so I'm going to turn this into the log of x divided by the log of 4. Okay. That's also wrong. So remember, the only time you can use the quotient rule is if you are dividing this one thing that's inside the same logarithm. Okay, so like in this blue piece up here, we have one log and then one set of parentheses. And in that set of parentheses, we have 2 things that are being divided. So we can separate those 2 things to get back to our original problem. All right, let's do these last couple then. So here I have a bunch of logs being added and subtracted together. I'm going to start by getting rid of all the constants in front, which is going to give me a lot of exponents. And then I'm going to start combining things using the product and quotient rule. So these first two logarithms are being added together, which means that I can combine them by multiplying them. And then the last log I'm subtracting, so that means that z to the fourth is going to go on the bottom of the log. Okay. So I've condensed all those logs into just one. All right, let's look at my last one. So I have the log base 3 of 5 plus the log base 3 of 10. So since I'm adding two logs together, I can go ahead and multiply the 5 times the 10 to get log base 3 of 50. And then I'm done. Okay, log base 3 of 50 is condensed into one log. Okay. I hope this was useful for you as you're learning to expand and condense logarithms using logarithm properties.